Let's start from the balanced YY connection. So first of all, balanced system means a balanced YY system means is a three-phase system with a balanced Y connected source and balanced Y connected load. Y connected source and Y connected load. That means each of the phase voltages are equal, each of the phase impedances and each impedances are equal. And Y connection means there is a neutral, there are three phase, that means three phase four wire systems are inevitably got into it. Now you can see here that is the exact figure of a balanced YY system. As you can see, VAN is a source impedance. Each and every uh, phase has a source impedance. It can be given, it can't be given. That's not the fact. But the fact is that ZL, 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 each loads are equal to each other. There are nothing changes. There is no unbalanced load. That is a balanced load. And VAN, VBN and VCN, all other voltages are equal as it is known as balanced phase voltages. And there is a neutral connection here, and neutral load also has been given here. So another thing is that ZL is here. ZL means particularly uh, line impedance. That means there are three major impedances in a phase. First of all, the source impedance ZS, second the line impedance ZL, and third the load impedance Z capital L. And if we just adding up the three impedances, we can find out the y connected impedance per phase, that is known as impedance per phase. As we know, in Y connection, if it is a balanced load, each and every phase has equal load. There will be no changes in the loads, and the source, the line and also the load impedance, these three impedances are have been adding up because it is in series. So we have to make it showing the source, line and load impedance. That is very much practical approach, because in practical we use the three phase generators that generates the power, and these powers really transmits and distributed throughout our systems. The systems like our households, like our factories, they use this kind of powers. So there are some transmission lines that the power has been flowed. So the transmission impairment, that we know that the transmission line also has impedance, so it will also make some losses. So we have to also consider the line impedance. There are some source impedances too, and also the load impedance, that means the load that we will use in each houses, that will also adding up to the factor. So now after adding up, we can now drew up a very common design like this. Just see this balanced YY connection, VAN, VBN and VCN3, and there is a current IN, there is a current IA, there is a current IB, there is a current IC. Because the positive sign is here, so the current will flow from this direction to that direction. And the after adding up every impedance of ZY are equal, so that is a balanced YY connection. So that is known as pretty much a balanced YY connection, and each other currents will flow through it. Now coming back to the point, assuming the positive sequence, that means the phase voltages, if we assume it a positive sequence, keep on your mind, in every math you have to look after the sequence also. It is ACB sequence or ABC sequence. It is, if it is positive sequence ABC, you have to follow the guideline of the previous ABC sequence. That means VP 0 degree, VBN will be VP 120 degree, and VCN will be VP plus 240, that means VP minus 120 degree. You have to follow this kind of sequences. So just look upon the previous lectures that you can easily understand this sequence term. And now as you can see here, that phase voltage, the line to line and line to neutral voltages. Phase means that will be line to neutral voltage, that is a neutral and that is a line voltage. So that is known as the phase to line to neutral voltage. That means that is known as phase voltage. So VAN is 0 degree, VP 0 degree. As it is positive sequence, VBN will be minus 120 degree and VCN will be plus 120 degree, assuming the positive sequence. Now coming back to the point again, the positive sequence. Okay, what are the line to line voltages? In previously we have seen the voltages of line to phase voltage, and another thing is line to line voltage. The line to line voltage will be the voltage between two phases. Okay, that means VAB, VBC, VCA, that is related to the phase voltages. Okay, for example, if we say VAB, that will be VAN plus VNB, or you can say VAN minus VBN. Okay, let's just go on top of the circuit to understand this clearly. Okay, as you can see here, it is VAN, it's VBN, and it is VCN. If we take voltage from A to B, that means if we take voltage from this point of view, if you add a voltmeter here and find the voltage from this point to that point, that will be VAB, A point to B point. Okay, if it is plus and if it's a minus. So as you know, the notation system, VAB means VAN minus VBN. Why we can write this? That is a very simple notation factor that we know. If we take the difference between two neutral to line voltage, this voltage and that voltage, we can find out the difference. The difference will be the voltage between these two. Okay, that is the basic. So if it is a VBC, what will be it? If it is a VBC, simple. B is particularly taken as first and C will be last. So in these 2 points, if we set up a voltmeter, we can easily find out VBC. VBC means VBN minus VCN. You can also find out VCN too. VCB. VCB means that will be plus, that will be minus. You can take these 2 points voltage, so you can easily find out this. That will be VCA, not VCB, VCA, VCN minus VAN. Very simple. So these voltages are known as phase to phase voltage, and most probably that is known as line to line voltage, because there are 3 line of voltages are applying. The 3 line to line voltages apply. They are particularly known as line to line voltages, not phase to phase voltages, line to line voltages. VAB, VBC, VCA. So if it is VAB, that will be VAN minus VBN. Not look in that position, just if you understand this, just take it. So that will be VP 0 degree minus VP minus 120 degree that you have taken previously here. Just put these values from here to this there. Okay, after that make it complex, you can get this. Next time I will show you how we could calculate these things. But